So for slope, we use this equation, m equals y sub 2 minus y sub 1 over x sub 2 over x sub 1. Another way we've heard about it is, well, I guess the first thing we've heard about rise and run before. So which variables represent the rise, which ones represent the run here, I guess, is my first question. Just from classic slope. So the y value should represent the rise, right? Which makes sense. And the x values represent the run. All right. So today, yeah, like I said, just focusing on determining the gradient of a line joining lining the points. 2 points. So that slope is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And it honestly doesn't really matter as long as we're consistent. Like if I use 3 as y sub 2, then I have to use 8 as x sub 2. And in this case, I get 2/4, so our slope would be 1/2. That's it. That's the idea. So rise over run. And I could technically do it the other way as well, where I say 1 minus 3 over 4 minus 8, because then I would get negative 2 over negative 4, which still gets me that exact same slope. So like I said, it doesn't matter. The nice thing about slope is it doesn't matter as long as we're consistent and say this is x2, y2, and this is x1, y1. Otherwise, it won't make a difference to our calculations. All right, so that's one way to determine slope. Another way we might have to determine slope is example 6, if I'm just given graphs and I need to figure out the slope from these values here. So for examples A and B, I want you guys to try and determine what you think the slopes will be for these 2 lines here, examples A and B from problem 6 here. These two, there's a couple different ways we could do it. The first is we could identify 2 points, like in example A, and then we can just say, okay, I'm going to do 4 minus 5 over 4 minus 2, and I'm going to get negative 1/2. That would be my slope for the first one. That's one way I could do it, just to find 2 points and then use the same equation. The other way I could do it is how I mentioned rise over run. We can see, okay, this thing is going up 2, so that's a positive 2, and then to the right 5. So it'd be 2/5 would be our slope for something like example number 6. Okay, so that's the idea for these types of problems. A couple other slopes I want to mention is it's possible to have a 0 slope, or we might say 0 gradient. And that would be a horizontal line. Where the rise is 0. All right, so that could happen. We could have something like 0 over 7. So that'd be a slope of 0. Or I'll just say 0 over x. We'll just do a more generalized form. And then the other thing that could happen is we could have an undefined slope. or gradient. And an undefined slope or gradient would be a vertical line. And that's when the run is 0. And we can tell algebraically because we might get something that's y over 0. Anything divided by 0 is undefined. So those are just two slopes we need to watch out for, and we need to know the difference between a 0 slope and an undefined slope. I know that can sometimes be probably one of the trickier things about slope. Other than that, hopefully slope is not too tricky for us. Okay? And just remember, just when we're talking about slope or gradient, slope is the steepness of the line. All right, I mean, hopefully we know that, but it's just steepness and direction, I guess. Because positive can tell us it's going up, negative tells us it's going down. But hopefully that's not new news for us, right? We've been dealing a lot with slope with calculus, and now we're going back to much simpler problems than what we had before. All right. Now, example 7 here. Go ahead and determine the slope of a horizontal line that passes through the point 1, 2, and then show the gradient of a vertical line that passes through the point 1, 2. Show that they're undefined. One's undefined, and show that the other one's 0. All right, so prove it to me. So that means just find some other points and show me algebraically. Okay. All right, and as we can see, like I made my own points. You can pick wherever you want for your points as well. But I just picked a point E that was 1, 5, and I showed that, hey, the denominator of this fraction would be 0. That's how I can prove something's undefined. And then for example 7, I just chose the point F, 4, 2. You could have chosen 3, 2, 2, 2, 0, 2. A lot of points you could choose there for that one. Pretty straightforward though. Nothing crazy here. All right. And then example 8, find the slope of line AB that passes through -2, -11, and B, -0, -5. And it says this one, do it using a graphing calculator, which, I mean, you just need to be able to write the equation of a line in order to use a graphing calculator to do this, to find the slope. But otherwise, you can still use the slope formula to do this. Okay. So I didn't even know you could do this on a calculator, but apparently you can type in the 2 points, the ordered pairs, and then there's a functions button on your graphing calculator that allows you to find the slope between those 2 points. That's kind of cool. But slope is such hopefully a simple concept for us. That's not something we have to do a lot. Okay, but let's go ahead and write an equation for the line for these ones so we can get a little practice with that. And sometimes when we have to do subtraction of a negative number, we just have to be careful with that. So -5 minus -11 is really -5 plus 11. And 0 minus -2 is really 0 plus 2. So I should get a slope of 3 here. And then if I want to find the y-intercept for this problem, if I do want to write an equation for it, I can plug in either point. And we'll find out that the y-intercept is indeed -5. So our equation is y equals 3x minus 5. If I wanted to write an actual equation for it. Okay? All right. We're going pretty quick today. I mean, I say this is pretty straightforward with slope. Not too bad. Last one, word problem. So I want you guys to try and use your knowledge of coordinates here. All right, and see if you can find the height of station B above the ground. So you're looking for H on station B. So why don't you guys go ahead and work through that for a second here, and then we'll check our answers, and I'll let you go. This last problem. So this one gives us the coordinates of station A is 30, 60. And then the coordinates of station B are 230, H. And then it gives us the slope is 0.6. So we can set m equal to our values here. H minus 60 over 230 minus 30. And then it's just a matter of solving algebraically for the h value. So I get 0.6 equals h minus 60 over 200. Multiply both sides by 200.
Is it not for 230?
Well, it was 230, but it was 230 minus 30, because we're doing the slope equation.
Okay, gotcha.
So that's why it became a 200. And then 200 times 0.6 should be 120. And then we add 60 to both sides. And we get h equals 180. Alright, should be our final height there. So we can say station B is 180 feet, no, meters. Station B is 180 meters above ground. Okay, well,